Hello everyone, my name is Aman.
And my name is Anish, and we are going to demo Rover Simulation, our project for SER 574. This project was done by the whole class with 5 different components. And basically, the intention of this project was to create a simulation for an autonomous rover and analyze its movement around the maze to see which combination of sensors with algorithms does this best. So let's look into the UI implementation. Over to you, Amanjot.
Okay, so when the user runs the program, this is the first screen that comes up. The user has two options to select the UI interface or the experimental design interface. The UI interface is to see the simulation of the rover exploring the maze, and the experimental design interface is for the scientists to run the experiments, a number of trials on the same maze and generate data to analyze the performance of algorithms and using different sensors. So first, let's see how the UI interface is being used by the user. So after the user selects UI interface, this page, the user gets the option to select maze coverage, the algorithm type which will be used to explore the maze. As we can see, we have implemented multiple neural network algorithms and the random direction exploration. So let's go ahead and select one. The user can select the size of the maze as well as the maze complexity and the sensor which will be used. So let's see and run the simulation once. So we can see on the left side of the screen the option selected by the user. And if I click on create maze, it sets up the maze for the exploration to begin. The manual button moves the rover only one command at a time, and the automatic button will automate this process and the rover will start exploring in the maze. Here on the left side of the screen, we can see the live sensor data generated by the robot, and the rover life that we see here is the current live of the rover. So we have started from 3600, and for each step the rover takes, we are reducing 1 second from its life. So there can be multiple options when the rover will stop exploring in the maze. One can be when the battery life expires, or since the user has selected the percentage of maze that needs to be explored. So once that percentage is complete, the rover will stop the exploration. On the right side of the screen, as we can see, the part only that the rover can explore or can see is being displayed to the user. And now the simulation has stopped since the rover has achieved 85% maze coverage. That's the coverage percentage that the user selected before running this simulation. Now let's go back and try to run some more explorations using different options. So backpropagation is another algorithm that we have implemented. Let's try to change the maze size and the sensor, and let's see how the backpropagation algorithm work. So as we can see on the right side of the screen, that the range sensor has more visibility than the proximity sensor. So while exploring, the more amount of maze is getting discovered by the rover. The algorithm teams have trained our neural networks to explore the maze around the corners and then go towards the center. That is why the backpropagation algorithm is behaving in this way. So similarly, this exploration will also stop if the maze is covered as the intended percentage of user given is achieved, or the battery of the rover expires. Now let's see the implementation of another sensor, which is a bumper sensor, and see how the maze gets explored. So the expectation here is that the bumper sensor can only sense once it bumps into a wall or some obstacle. So as we can see on the right side of the screen, the maze gets generated based on the bumper sensor bumping into walls, and the sensor cannot see any other obstacle. So this is how the bumper sensor works, and the maze will be explored based on that. Now this simulation is for another algorithm that we have implemented, feed forward. Let's see how it performs. So this is the implementation of feed forward. So that was the demo of the UI interface for the user. Now let's move on to the experimental design interface, which is designed for the scientists to run experiments and number of trials on the same maze using neural network algorithms. So Anish will be giving the demo for the experimental design UI. Over to you, Anish.
Yes, so as you can see, this is the main screen where we can select the experimental design implementation from here. So in this screen, as you have seen earlier in the UI, all the options are similar, but there is one option which is different from that, which is number of experiments and the experiment type, which is training data or testing data. So we have included this because this section is basically to have as much as experiments for simulation and collect data for training or testing the neural networks. So let's just run one experiment here with a combination of all the parameters. So once we create maze, the experiment 120 has started. So this will run until all the simulations are completed. So it takes quite some time to complete all the trials for one experiment. So after all the trials are completed, we can see the statistics of our experiment. So let's go to the stats part. So on this screen, as you can see, the supervisor can see and analyze the data which gets collected by all the trials. So let's input 120, which was our experiment ID, and see what graphs we got. So as you can see, this graph shows time versus number of trials, a line graph. And in the above, you can see that there are 4 options, and let's select points scored. So it creates a graph for points scored for all the trials by the rover. And that section shows you the rules. So 10 points are added for unvisited cell and 2 points are deducted for a visited cell. Let's check some other graph, maze coverage. And below, if you can see, we can change the graph into a bar graph. So the user has an option to change from bar graph to line graph just to visualize data better. And below, if you can see these values, these are the values which are selected by the user while doing this experiment. But we can change these values at the right side. So let's change it to back propagation 30 by 30 maze and 0.16 for proximity sensor. Let's see. So you can also fetch some previous data analysis of previous experiment for all the parameters. So this is how the supervisor can analyze all the data collected by the rover for all the trials. Also, he can fetch by some trial ID at the right. And this data which is getting collected for all the trials is getting stored for testing as well as training for all the neural networks, depending on what algorithm the user has chosen. So this part is everything related to experimental design implementation.